Hello, right, we're talking now about a look at Tom Bethell's interview on relativity, representing Beckman's viewpoint, and this is what I'll be talking about. But first of all, I need to deal with something I should have dealt with last time. Right, for the type 1 people who decide they understand Einstein's relativity, this splits into two groups. Type 1a, Einstein's relativity makes sense to them and they believe it. Type 1b, Einstein's relativity it's nonsense. They understand Einstein's relativity as being nonsense. Right. So now we look at this article, Did Einstein Not Understand Maths? There. This is an article by Johnson Klaus in 2010. He's saying, did Einstein not understand maths? Maybe you can make it bigger. What can you expect from a mathematical theory developed by someone who did not understand mathematics? And this is basically Einstein. Einstein did not understand maths, and so he's developed a mathematical theory. Princeton is a madhouse and Einstein is completely cuckoo. And this is what Robert Oppenheimer was saying in 1935. Robert Oppenheimer was the person in charge of the Manhattan Project, the scientist in charge of it. So Klaus is telling us, use your brains. How are we going to choose between fact and fiction, between science, pseudoscience and nonsense, and the flood of information overwhelming us every day? Well, use your brains. What else? Let's test this approach on the foundation of modern physics, Einstein's theory of relativity. This is sort of the headline in 1919 when Einstein became famous. So it's making a claim, a book for 12 wise men. No more in all the world could comprehend it, said Einstein, when his daring publishers accepted it. So he's talking about, when he's talking about relativity, this myth coming along that you've got to be very clever to understand it, and only sort of like 12 men in the world are clever enough to understand it. So you've got this thing about nobody understands relativity. Nobody understands, nobody even claims to understand. But relativity theory is very difficult, you say, and my brains are not sharp enough to make it possible to say anything sensible about this subject. Don't panic, you are in good company, because not even expert physicists claim to understand. So here we go, some examples. Many people probably felt relieved when told that the true nature of the world could not be understood except by Einstein and a few other geniuses who were able to think in 4 dimensions. They had tried to understand science, but now it was evident that science was something to believe in, not something which should be understood. And this is Nobel laureate of 1917 in physics saying this, Hans Olfen. So what was happening is, if you don't understand a subject, then what do? You are being forced into a position where you're going to take it on faith that you should believe in it, and that's turning it into a religion. And you shouldn't do that. You shouldn't really do that with science. Right. The relativity of space and time is a startling conclusion. I have known it for more than 25 years, but even so, whenever I quietly sit and think it through, I am amazed. It is not the depth of mathematics that makes Einstein's relativity challenging. It is the degree to which the ideas are foreign and apparently inconsistent with our everyday experience. And this is by Brian Greene in The Fabric of Cosmos. I think that might be his book. He's done various TV programs promoting Einstein's relativity, and he's saying here, he's accepting it's apparently inconsistent with our everyday experience. He's not really going far enough. It is just totally inconsistent and nonsense. That's what he should be proclaiming. But he's just going to say it's apparently inconsistent. But I think when you really look at it more, it's more than apparent. It is inconsistent and it's nonsense. This is a witty comment from Charlie Chaplin to Einstein. People are applauding me, that's Chaplin, because everybody understands what I say, i.e. in his comedies. And you, this is Einstein, because nobody understands what you say. So the joke there is nobody understands what Einstein's talking about. Next is a comment by Einstein. Why is it that nobody understands me and everybody likes me? And when he's talking there, nobody understands his theory of relativity. Right. And this is a bloke saying this. The general theory of relativity, the name is repellent. Relativity, I have never been able to understand what the word means in this connection. I used to think that this was my fault, some flaw of my intelligence. So he's looking at relativity and the pressure is on him, you don't understand it, then it's probably a fault for yourself. So rather than look at the theory and say, well, this is nonsense, you look at it and say, I don't understand it, and you're then pressurising, looking inwards on yourself, and it's affecting your perception of how intelligent you think you are. But then it goes on, but it is now apparent that nobody ever understood it. So basically, from my point of view, nobody ever understood it properly because it's nonsense. Probably not Einstein himself. So he's saying that Einstein probably didn't understand relativity as well. So this is what we're getting. Einstein didn't understand what he was talking about, and that is his theory. You should really conclude it's nonsense, but the pressure is on you. I used to think that this was my fault, some flaw of my intelligence. You getting this pressure on you that you think, well, it must be my fault that I don't understand it. But really, you should be reaching the conclusion it's nonsense. Right, this is Larry. He's written a book on relativity, and Einstein's making a comment on it. I myself can hardly understand Larry's book. And this is Einstein about the first textbook on special relativity in 1914. So Einstein didn't understand this book on special relativity. So this is another highlighting of what hope have you got if somebody who's proposed a theory doesn't understand the theory himself. He's just not talking sense, it's nonsense. Thus, this is another bloke folk who's saying about it, thus we can sum up, general relativity cannot be physical and physical relativity is not general. So basically saying general relativity is not a physical theory. It's just no use to you in physics, it's just nonsense. Right, next one, this is a comment by Einstein, I think. Scientific American once ran a competition offering several $1,000s for the best explanation of Einstein's general theory of relativity in 3,000 words. And this is what Einstein's saying. I am the only one in my entire circle of friends who is not entering. Einstein ruefully remarked, I don't believe I could do it. So he doesn't understand the theory, and he doesn't think he would be able to win several $1,000s in a competition trying to explain the theory. Einstein, my upset stomach hates you. Hates your theory, i.e. of relativity. It also hates you yourself. How am I to provide my students? What am I to answer to the philosophers? This is what Ernst was saying. So he doesn't like the theory. Right. The general public looked upon relativity as indicative of the seemingly incomprehensible modern era. So suddenly you're in the modern era and it's incomprehensible, and relativity is what you are coming to expect. Educated scientists despaired of ever understanding what Einstein had done. So people who'd been educated in physics before Einstein look at what Einstein's saying and they don't make sense of it. They don't make sense of what Einstein's saying. And political ideologues used the new theory to exploit public fears and anxieties. So there's political philosophies, ideologies being used by people to use the theory for their own political ends. all of which opened a rift between science and the broader culture that continues to expand today. So Einstein's relativity was used as a political weapon, and it was used to split society between science and the broader culture. And this is David Cassidy pointing this out. Right, you've got a picture here, Einstein poking his tongue, and he's thinking to himself, I don't understand relativity, do you? Okay, fine. Nobody understands relativity, not even Einstein, but how are we then to judge? So there's two possibilities. A, since nobody understands the theory, it is most likely correct and meaningful. Or B, since nobody understands the theory, it does not make sense, i.e. the theory then does not make sense, which isn't meaning it's nonsense. And that ties into what I'm saying here. You can be the type 1A, Einstein's relativity makes sense to you, or you can be the type 1B, Einstein's relativity is nonsense. Go back. So we've got to decide between these two possibilities. Are you going to believe A or B? So, what do you believe, A or B? To seek an answer, let us take a look at the inventor Einstein himself. Maybe he can give us a clue. Like most of us, Einstein had difficulties with mathematics. So this is Minkowski, Einstein's maths teacher. He says Einstein was a lazy dog. And this is Einstein. I neglected mathematics because my intuition was not strong enough to differentiate the fundamentally important from the dispensable erudition. So Einstein's saying he was rubbish at maths basically. And this is something supposed to, Einstein said to Chapman, or maybe Marilyn Monroe, or something like that. Do not worry about your difficulties in mathematics. I can assure you mine are still greater. So he's admitting, Marston's admitting he's no good at maths. And that's not the myth they like to put onto you, that Einstein was a mathematical genius. So you've got all this evidence that Einstein was not any good at maths. So mathematics can do wonders and so forth. Yeah, so he's basically going about, can mathematics really do wonders? It's not too important, so we can move on down to this bit. There's another. So that's basically it. And we're moving down, Einstein-like contradictions and ambiguity. So in 1905, what he's saying about special relativity is interpreted as there is no ether according to the special theory of relativity. Then in 1920, he's saying there is an ether according to the general theory of relativity. So he's changed his mind. He's saying one thing one moment and saying the opposite later. That's basically what he's doing. He's changing his mind. How can you make sense of something from somebody who is so messed up? So this is the foundation upon which we're going to now look at this little talk from Tom Bethell. This is on a program. Let's show it. Best-selling author Tom Bethell dares to challenge Einstein's theory of relativity. Who is right or wrong? You be the judge. Bethell is the senior editor of American Spectator magazine. And this is something, a conservative roundtable program. So we'll start this up and see what we find out.
Welcome to Conservative Roundtable. I'm Howard Phillips, Chairman of the Conservative Caucus, which sponsors these broadcasts. We're very privileged to have as our guest Tom Bethell. Tom is a journalist in Washington, D.C., a senior editor of the American Spectator. He was, at one point, Washington editor of Harper's and an editor of the Washington Monthly, both of which magazines have seen their better days, by the way. He has written for many other magazines, including Fortune, the New York Times Magazine, and the Atlantic Monthly. He has been a columnist for the Los Angeles Herald-Examiner and the late lamented Washington Star. He also is a media fellow at the Hoover Institution in Stanford. He's written several books, including The Noblest Triumph, Property and Prosperity Through the Ages, very good book, The Politically Incorrect Guide to Science. The writer and high-tech analyst George Gilder has said that Tom Bethell commands the most eloquent prose in American journalism. In 1988, a collection of his journalism was published under the title The Electric Windmill. Tom Wolfe, who usually dresses in white suits, said that the book, quote, establishes Tom Bethell as one of our most brilliant essayists. His new book on Einstein's theory of relativity is written for the benefit of laymen, includes no math, and argues that the facts of physics can be more simply explained without relativity theory. In plain language, it advances the views of Peter Beckman, a great man, now deceased, who wrote Einstein.
So Beckman advanced the view of Beckman, and we can go here. This is Peter Beckman, Dr. Peter Beckman, and he's got a few talks on the internet, but unfortunately not to do with relativity, from what I can see. So this is what Wikipedia has to say about him. Sadly, he's passed away in 1993. He was Professor of Electrical Engineering and Libertarianism and nuclear power as issues, and later in his life he challenged Albert Einstein's theory of relativity and other accepted theories in modern physics. So this is Tom Bethell is picking up from Dr. Beckman this opposition to Einstein's relativity. Okay.
+2, and for years taught at the University of Colorado. A graduate of Oxford University, class of '62, where Mr. Bethell studied philosophy, physiology, and psychology. Tom came to the U.S. in 1962. He's married to Donna Fitzpatrick Bethell, chairman of the board of Christendom College, an excellent institution from which my youngest son graduated. This is an interesting book, and believe it or not, this is going to be an interesting program. Even if you're not a physicist and don't know anything about science, because I'm in that category. But let me begin by asking you, Tom, Stephen Hawking once wrote that, quote, if one wanted to live longer, one should keep flying to the east so that the plane's speed is added to the Earth's rotation. What does that mean? Well, you have.
What does that mean? So, but it's unfortunately, it's a difficult question to get into first timers. So, Tom Bethell has to do a lot of background information before being able to address a question like that, and I think they divert from it in the end. So, we've got to try to explain Einstein's relativity, and then say what's wrong with it. So, it's difficult to suddenly get into a question like that. So picking it up again.
Earth's rotation. What does that mean?
Well, you have to go back a bit. First of all, I'm promoting or discussing in this book the theories and the ideas about relativity of Peter Beckman, who was a good friend of mine. He wrote.
So this is Beckman again. I'll show you the picture again. So he's promoting the views of this person, Dr. Peter Beckman. I'll maybe get the sound up a bit. Bump the sound up. Play.
Wrote an excellent newsletter called Access to Energy.
I read it regularly.
He came to this country from Czechoslovakia in the 60s, and he was very eminent and I think really brilliant scholar in math and science and physics. And I think he actually taught electrical engineering. Anyway, I remember he told me once that I asked him what he was working on, because we used to talk quite a lot, and he said that he was working on a revision of relativity, that the whole thing could be explained without relativity theory, the physical anomalies that had led Einstein to propose the theory of relativity, the special theory, in 1905. And so I thought, well, that's very interesting. And because I hadn't heard anyone talk about that, and I knew Peter was very smart. So I said, okay, well, I will, you know, he'd written this book called Einstein Plus Two. That came out a few years later. And it was actually quite difficult to understand because it was filled with math and stuff. So I said, well, why didn't you do a plain language version of this? And he said, well, I thought about it, but I thought it would be taken more seriously by the physicists if it was in the language of mathematical physics. So I said, well, I'll do it. I'll write a plain language. He said, that'd be great. I'll help you. Then, unfortunately, a few years later, he died.
So what we got is two books. One's the technical book with the maths in it, and the one's to the general public, trying to explain things a bit more simply.
Quite quickly, at the age of 68. But meanwhile, he had converted somebody else to his ideas, somebody called Howard Hayden, who taught physics at the University of Colorado. University of Connecticut, sorry. And anyway, so Hayden was able to help me. And I did really need some help, because when you work on these things, you think you sort of understand it, but then when you actually get to writing it, you find a lot of things you don't understand. So Howard Hayden helped me, and then finally I was able to get this book finished just recently. And in fact, this is the first program, or, you know, television or even radio that I've done discussing it.
Thank you for being here.
Thank you. Anyway, so what we need in order to understand something about relativity, I mean, it is difficult, I guess, to understand, although I think if you were to read my book, you could kind of get the point.
Let me stop you here.
All right.
For our audience, explain as succinctly and simply as you can, what is Einstein's theory of relativity, special and or general?
All right. Very simply, although the idea is impossible really to accept.
So he's saying, could explain Einstein's relativity, and he's saying it's an idea impossible to accept. So this is the point of view. If we go back, this is the point of view. You understand Einstein's relativity, and you conclude it's nonsense. It's perfectly valid point of view. Perfectly valid to look at the theory of relativity and decide it's nonsense. Your understanding of the theory is it's nonsense. It's impossible to accept it. Start it again.
Einstein's theory of relativity, special and or general.
All right. Very simply, although
explain as succinctly and simply as you can, what is Einstein's theory of relativity, special and or general?
All right. Very simply, although the idea is impossible really to accept, it's the idea that the movement of the observer affects space and time. It actually, reality becomes sort of observer dependent, and this is what Beckman could never understand.
You talk in the book about...
Beckman could never understand that, and I think really it should be more said that Beckman understood that what the idea was. He just did not accept it, and he thought the idea was probably nonsense, which is the type 1b conclusion. Saying you don't understand it, but really what you really mean is you understand it and you think it's nonsense.
And this is what Beckman could never understand.
You talk in the book about a man looking at another fellow's watch.
Oh yeah, if you and I have right now, if you and I have our watches on, we've got identical watches, both absolutely going at the same rate, and I move, I see your watch slow down. That's to say, and my watch doesn't change; it's still going at the same rate. And you see my watch slow down, and you think, well, how can just the movement of one person affect the rate of the passage of time with somebody else who is not moving? And this is right at the heart of what relativity is trying to say, and what Einstein postulated. He assumed, he didn't demonstrate, he assumed.
Right. This is the point of view that Einstein assumed the speed of light was constant, and that's the speed of light is constant for inertial frames in a vacuum free of the influence of fields in the situation of special relativity. So we're treating it from that assumption sort of thing. Now, go back. As I explained in my talk, where is it? The lie. As I explained in my talk, the lie on which Einstein's relativity is built, what happens is they were unable to measure the speed of light as being constant, and so they then decided to define the speed of light as constant, and that is a complete change from the perspective of saying you assume the speed of light is constant and you want to check whether the speed of light is constant by experiment. That was unsuccessful, and what they really did was change to a theory where you're defining the speed of light as constant. So this is one of the places where the ambiguity is starting. So Bethell here is dealing with the proposal that the theory of special relativity is that you're going to assume the speed of light is constant, and you're then going to check by experiment whether it is constant or not. But since then they've messed it up further.
Doesn't affect the rate of movement of one person, affect the rate of the passage of time with somebody else who is not moving. And this is right at the heart of what relativity is trying to say, and what Einstein postulated. He assumed, he didn't demonstrate, he assumed that
so he didn't demonstrate, he just assumed it. If you're taking it from that perspective, then what? It's not the same thing.
the speed of light has to be a constant at all times, irrespective of the movement of the observer. So if the observer, if I move towards that light bulb there, then the space and time in the reference frame that is not moving has to adjust so that one divided by the other, space divided by time, always gives you the same quotient, always gives you the same c, the speed of light. So essentially, time has to adjust and space has to adjust in order to keep the speed of light a constant. Why does the speed of light have to be a constant? Because Einstein postulated that.
And that's nonsense postulation, really, to postulate something that is nonsense, because you're then forcing the space and time to change. It's nonsense, but that's what he's done.
In order to keep the speed of light a constant. Why does the speed of light have to be a constant? Because Einstein postulated that. So it leads us into these absolutely absurd and impossible things to believe.
So it leads you into absurd and impossible things, and that's why you would conclude it's nonsense. Einstein's conclusions are just derived from something which is nonsense and leads to more nonsense. Pick it up again.
Speed of light have to be a constant because Einstein postulated that. So it leads us into these absolutely absurd and impossible things to believe, including the fact that space and time is dependent upon what the observer does. And this is really a totally unacceptable, this was unacceptable to...
Totally unacceptable, and he's saying it's totally unacceptable to Beckman as well. So you can then construct a theory where you don't have that sort of nonsense. Go back again a bit. Totally unacceptable.
It does. And this is really a totally unacceptable... This was unacceptable to Peter Beckman. He said, I just can't believe that. There has to be a simpler way of looking at this.
Has to be a simpler way of looking at it. Einstein is just muddying the waters. He's just talking nonsense. There's a simpler way of doing it.
Dependent upon what the observer does. And this is really a totally unacceptable... This was unacceptable to Peter Beckman. He said, I just can't believe that. There has to be a simpler way of looking at this. And this is what he worked out in his book, in Einstein Plus 2. So I could go into a little bit more. There's a famous experiment by the Michelson-Morley experiment. Did you ever hear about that when you were at Harvard?
No, I did not.
All right. Well, anyway, there was this guy called Albert Michelson who in the 1870s, 1880s, tried to detect what is called the ether. Now, the idea of the ether, sound waves have to have a medium that they travel in, and that is air. So there was obvious that light also was a waveform. There are wavelengths of light, different wavelengths, so there had to be a medium in which light rays travel, and that was called the ether. And so it was assumed that the whole of space, that ether filled the whole of space uniformly, and the Earth, because it's going around the sun, is moving through this ether all the time in its orbit around the sun, you see. So he figured that you would be able to detect the Earth's movement through this ether. As it were, if you're in a car, you can stick your finger out of the car window and feel a wind. So there should be an ether wind. So he set up this experiment, which was very refined. It was done in Cleveland in 1887 with somebody else called Morley, Michelson and Morley, and they tried to detect the presence of this ether, and they could not detect it. This became one of the most, perplexing developments in physics in the late 19th century.
So you're saying they could not detect the ether, but unfortunately that wording is not quite correct. It's what they sort of tell you. They tell you that the result of the Michelson-Morley experiment is a null result, but actually there was a very small effect. They did have the light speed as variable, and it was a very small effect. It was smaller than what they expected it to be, so as an approximation they were taking that to be a null result. But when you actually do the experiment in more detail, you find that it's not a null result. It is actually, light speed is variable. And I've done that one. So Dr. Beckman. So here's the paper by Tom Bethell. He's given a summary of his book. Questioning Einstein, is relativity necessary? He gave this summary in 2010. I summarised my 2009 book, Questioning Einstein, is Relativity Necessary?, which in turn simplifies Peter Beckman's Einstein plus 2 book from 1987. So Beckman's assumption was that the luminescent medium, which Michelson failed to detect in 1887, is the local gravitational field, which attenuates the distance from the gravitating body. I don't think these wordings are sort of like correct, really. If they failed to detect it, what they detected a very small effect, and it was approximated as being a null result. But really they did have a small effect. It's just much smaller than what they were expecting. So I think a review I've got here is a bit better than the wording they got for this. This is a review of the book by Neil DeRosa. Right, and so we'll go through it. And Neil saying that a book by a great and established writer not like Tom Bethell, who is a long-time science writer and political columnist at the American Spectator, hasn't been officially reviewed yet, says more about those who pose as the intellectual and editorial guardians of literature than it does about the quality of this book or the stature of its author. In fact, it's an engaging, well-researched book about one of the most interesting paradigm struggles of the 20th century, and it's still ongoing. And it's still ongoing because people are still saying Einstein's wrong, and there's still people who want to support Einstein. So it's an ongoing struggle between these two camps. That Einstein's special theory of relativity was influenced and made quite popular by the relativistic ideologies of its time, 1905, seems to this writer a foregone conclusion. So Einstein's relativity is a product of the political and philosophical beliefs of the time, Einstein was influenced by them, and he came up with a theory of physics based upon that sort of ideologies of the time. But it was the Michelson-Morley experiment that failed to detect the luminescent ether, which gave special relativity scientific credibility. So it's back to that Michelson-Morley experiment, and it's really a question of that Michelson-Morley experiment having a very small effect, and that small effect is assumed to be a null effect, be null result, which means of no detection of ether. But Michelson himself soon doubted its conclusions and proved it in the later Michelson-Gell experiments, which did detect an ether. So Michelson, from Michelson-Morley experiment, did the experiment again, and he did find an ether. So they're still trying to, the believers in Einstein are still trying to impose on us the result of this experiment of Michelson-Morley, which didn't detect an ether in a very big amount. And actual fact, the experiments later done did find the ether. Right. Lorentz, a contemporary of Einstein and a scientist of equal stature, argued in numerous debates with Einstein that all relativistic effects, such as the bending of starlight as it passes near the sun, were the result of light travelling through an entrained ether, which surrounds and moves with planetary bodies, otherwise known as the gravitational field. So Lorentz was advocating an ether, and he's still saying this ether exists. And Lorentz is the person who came up with the Lorentz transformations, which is the mathematics used by Einstein. So Einstein's using the maths of Lorentz. Einstein's saying no ether in 1905, but Lorentz is still saying there is an ether. And if you take into account Einstein was mathematically but incompetent, Lorentz wasn't. He's much more into it. And it's sort of like the inference is that ether would be the gravitational field, if you're looking at it from Beckmann's point of view. Other well-known physicists of the day also doubted the veracity of special relativity, especially its principle of space-time distortion. A few were Herbert Dingle, whose paradox asked the question of which clock would run slow and thus experience time dilation predicted by special relativity of two relativistic travellers, as for example two rocket ships in different inertial frames, i.e. going at different speeds relative to each other. So Herbert Dingle was a famous person who opposed Einstein's relativity, and he was mostly ignored, and he was pointing out paradox, which really is pointing out there is inconsistency in special relativity, but the people who believe in Einstein are trying to ignore that inconsistency. Another physicist, H. Ives, of the famous Ives-Stilwell experiment to test the Doppler effect of fast-moving mesons, became a lifelong enemy of Einstein because he felt that his results were being misinterpreted. So Ives, who's done an experiment which Einstein's relativity is supposed to be in agreement with, is disagreeing. He's disagreeing. He's saying his experiment is being misinterpreted by those people who believe in Einstein's relativity. And there were many others who disagreed with Einstein's fundamental conclusions. So you were having all these people who are disagreeing with Einstein's relativity. So Ives, Dingle, and so forth. Lorentz would be sort of like disagreeing with Einstein of 1905, who was being interpreted as saying there's no ether, but when you look at Einstein later on, he seems to change his mind and accept the ether. Right, even Einstein himself, as Bethell points out, later in life admitted that forces propagating through empty space without a medium in which they could be conveyed was a logical absurdity. So the idea that there's no ether is a logical absurdity, as Einstein was pointing out himself. So the theory which Einstein had in 1905 doesn't make sense. So when they're trying to impose on us his 1905 theory, Einstein himself abandoned that theory. And this is a fact never mentioned in textbooks or in other easy Einstein books. So these easy Einstein books and these textbooks are trying to impose on us the point of view from 1905 that there is no ether, when Einstein later on abandoned that idea. So they're trying to impose on us nonsense which even Einstein didn't believe in the end. In the later part of the 20th century, other scientific critics picked up on where Lorentz and his contemporaries left off. Among them were Tom van Flannen. I'm not really impressed with him actually. Carver Mead, I don't know too much about him, and Peter Beckmann. Bethell concentrates on Beckmann's critique, written in a technical book called Einstein Plus 2, in which the author claims that all the effects of both special and general relativity can be explained using classical physics. So, the point of view of many of us critics of Einstein's relativity is you don't need Einstein's relativity, you can just go back to classical physics. Bethell brings Beckmann's book down to earth from the arcane heights of Mount Olympus by rendering Beckmann's mathematical descriptions understandable to the layman. So, I think I covered that before, that Bethell is writing the non-mathematical book and Beckmann's writing the mathematical book. If you are interested in the history of one of the most pivotal scientific ideas of our time, if you have always believed that the world should make sense but would still like to know about the mysteries of relativity, this book may be for you. And this reviewer might add that although Bethell might not know it yet, this might be maybe his most significant book. So if you want to understand physics, all you really have to do, I think, is when you come to your conclusions about trying to understand physics, you split into two groups. Type 1A, they believe Einstein's theory makes sense. Type 1B believes Einstein's relativity is nonsense. All you have to do is become a type 1 person and recognise Einstein's relativity is nonsense. That's your understanding you should come to. This understanding you shouldn't come to. You're just deluding yourself. From the point of view of us type 1 people, if you're coming to this conclusion, you are deluding yourself. So, what we need is more people to become type 1B people and realise what Einstein was talking about is nonsense, and then we can have progress in physics rather than these people trying to retard our progress. Next. So that was that. That's the review there. So we can now get back to the interview. Pick it up. He's going on about the Michelson-Morley experiment.
For trying to detect the presence of this ether, and they could not detect it. This became one of the most, perplexing developments in physics in the late 19th century. That was 1887. So then Einstein came along a few years later, in 1905, with a special theory of relativity which accounted for this outcome. And in the course of the various things that Einstein assumed in his special theory, one was that the speed of light has to be a constant at all times, and this would account for why Michelson had been unable to.
So once again, we are going from the point of view that Einstein's relativity is assuming the speed of light is constant, and as I pointed out in this talk here, there's utter confusion over that issue. You've got the theory where you're assuming the speed of light is constant and then going to check by experiment to find out whether it is constant or not, and then you've got the theory where you're defining the speed of light as constant. So you've got this utter confusion between two different types of theory. So we're going along with Bethell was going along with a theory where you are going to assume the speed of light is constant.
Detect this effect, you see.
So is it 186,000 miles per second?
Well, that's the speed of light, but the Earth, because the Earth moves in this quite large orbit around the Sun, it's going at quite a high speed through this ether, and you ought to be able to detect it, presumably, but they couldn't. So Beckmann then comes up. There's one great idea that Beckmann had, which is the sort of a central point about his rival alternative theory, and that is that the ether does exist. Einstein then said the ether didn't exist. He said we will assume from now on the ether.
In 1905, Einstein was saying well, a point of view which gets interpreted as the ether doesn't exist. But later on, Einstein changed his mind and believes in the ether. So we're dealing with Beckmann's version of ether.
The ether does exist. Einstein then said the ether didn't exist. He said we will assume from now on the ether does not exist. Beckmann says yes, it does exist, but it's not quite what you think it is. It's not some uniform substance that fills the whole of space. It is, in fact, the local gravitational field. All celestial bodies, including the Earth, the Sun, have their own gravitational field, which is moving along. And in the case of the Earth, the gravitational field, obviously, is moving along with the Earth. So you stick your finger out of the car window to feel the wind. You don't feel the wind because the wind is moving along with you. But, and gets to the question that you asked, the Earth is also rotating all the time. Once every 24 hours it goes round. And it rotates within its own gravitational field, which means that there should be this ether wind that Michelson tried to find, but it would be much smaller because the rotational velocity of the Earth is much, much less than the orbital velocity as it goes around the Sun.
What about the theory?
So basically there is a small ether effect, and when they were doing the Michelson-Morley experiment, the first time they were expecting a big ether effect, they didn't find the big ether effect, and so it gets represented as an approximation that there is a null effect, and a null effect meaning no ether. But in actual fact, if you do the experiment more accurately, you find there is a small ether effect. The ether exists, and if you're assuming the ether doesn't exist, you're making a mistake. You're getting the experiment wrong, you are misunderstanding the experiment. So this is tied into the lie upon which Einstein's relativity is based. With there being an ether effect, that means there is variable light speed. If you're assuming that there's variable, if you're assuming that light speed is constant, you can do an experiment and you find what is a small ether effect, and you find that the light speed is variable. So you have disproved that theory. And so when they decide to instead go for the theory where you're defining the speed of light as constant, you are ignoring a small effect where the light speed is changing, and it's a total corruption of science when you're doing that.
Gravitational field, which means that there should be this ether wind that Michelson tried to find, but it would be much smaller because the rotational velocity of the Earth is much, much less than the orbital velocity as it goes around the Sun.
Small ether
What about
effect.
the theory that if you are in outer space for a period of time, you can come back younger?
Well, they have all of these, they have...
So that is a diversion. Suddenly, after talking about the ether, you've suddenly been diverted onto the twin paradox, and that is another level of nonsense, basically. As Bethell is going to try to explain, they've never actually done the experiment for the twin paradox. But of course, the people who believe in Einstein's relativity claim that they have done some sort of experiment, but they haven't.
Well, they have all of these, they have these experiments, the problem with, one of the problems with Einstein's theory is that it's filled with these so-called thought experiments, and one is this twin experiment where, you've got two twins of the equal age, one goes off and comes back and is younger. No such experiment has ever been done.
No such experiment has actually been done, and I should really have the relativity challenge here. Oh, twin. No, that's not it. Twin paradox. No, that's not it either. That might be it. Yeah. So, the group I'm with have issued this challenge to the people who believe in Einstein's relativity to explain the twin paradox, because when they try to explain the twin paradox they give lots of different explanations, and sort of most of those explanations contradict each other, so they don't come up with one coherent, consistent, non-contradictory explanation of what the twin paradox is. And this is, I think, we go back to, if we go back to this is where in this talk it is basically what the confusion is between whether you should, when you're talking about the twin paradox, are you only talking about it in the situation of special relativity, or do you have to bring in other things like general relativity, and you end up with talking lots of different ideas. It's just not one coherent, consistent explanation. It's just a mishmash of lots of nonsense. If I can pick it up again.
Have these are the problem with, one of the problems with Einstein's theory is that it's filled with these so-called thought experiments. And one is this twin experiment where, you know, you've got two twins of the equal age. One goes off and comes back and is younger. No such experiment has ever been done.
You don't believe that's true?
No, I do not believe it's true, nor did Peter Beckman. And for one thing, you cannot look at this from the perspective of special relativity, because for special relativity to apply, it has to be uniform speed in a straight line, no acceleration, no deceleration, and the twin has to come around and come back again. And so that screws everything up from the point of view.
The relevant word is that it screws everything up. So if you're trying to work out the twin paradox form of special relativity, are you ignoring acceleration, or are you ignoring general relativity, and lots of other different possibilities like that? And you're going from a thought experiment where you are assuming things and ignoring things. You just ending up with lots of mess as to what you're talking about. This is why the mess is coming from. They have not come up with one single coherent explanation of what the twin paradox mean. It's just a collection of mess.
No acceleration, no deceleration, and the twin has to come around and come back again. And so that screws everything up from the point
Screws
of
everything
view
up.
and you have to look at it from a much more complicated perspective of general relativity.
We have to take a break here, Tom. When we come back...
So they're having a break now, and I'll pick it up again after the break. So 15:10. This is path to the break.
Welcome back. I'm Howard Phillips, Chairman of the Conservative Caucus, and we're delighted to have as our guest author Tom Bethell, who has written a book which I urge you to read, Questioning Einstein, Is Relativity Necessary? Now that may sound pretty esoteric and far-fetched and beyond your normal interest, but this book is very well written. It will whet your appetite, and you're bound to learn something if you read it. And it's an easy read. It reads very well. You don't have to be a math expert or a physicist to read the book. It's a good book. It's very well written. Now, one of the things that has interested you, Tom, is the connection between relativity and relativism. And you have indicated that, quote, what makes relativity so hard to understand is that we are expected to believe that the external world is affected by the observer. Space and time are supposedly observer-dependent. And we touched on this before.
And so that's relativity, and if you reach a sensible conclusion, you should think something like that is nonsense. You shouldn't be messing around like that. But relativity is, as applied to physics, is coming from Einstein to get Einstein's relativity, and it's kind of a mess. And the next thing they do is they decide to apply relativity to morals, and so you get things like moral relativism, and so you're messing up moral systems. So if you're sort of believing in moral relativism, you are then sort of not caring what moral system a person has, and so if somebody's evil or whatever, it doesn't really matter within a moral relativist point of view. So that's basically nonsense as well. But when the critics of, or the supporters of Einstein's relativity, what they like to do is to divert onto the relativism issue, and they like to say that people were attacking Einstein's relativity because they don't believe in moral relativism. In actual fact is moral systems have been messed up, and also physics has been messed up by Einstein's approach to relativity. Both things have been messed up.
According to relativity, you and I have identical watches, and we are standing next to one another or each other. When I move, your watch slows down as I see it, but you observe no change in your own watch. At the same time, you observe my watch to slow down, but you observe no change in your own watch. Understanding why my motion affects time in your reference frame is the heart of special relativity. And you go on. And it hasn't been observed by experiment, but
Has not been.
Has not been.
Yeah.
Yeah. So that's a point. The people who believe in Einstein's relativity keep making false claims about how they've tested things by experiment, and when you actually look into it, you find they haven't. They haven't tested what they claim to have tested. And if you go back to this lecture talk I gave here, the lie upon which Einstein's relativity is built, often they will tell students of physics, that the constancy of the speed of light has been tested and confirmed by experiment. And that is a lie. And the truth is they never had an experiment which showed that. And so, because they never had an experiment to show that, they defined the speed of light as constant to try to overcome that problem. So basically they lie about experiments. They falsely represent experiments from their belief in in Einstein's relativity. They will make false claims about experiments.
And it hasn't been observed by experiment, but
Has not been.
Has not been.
Yeah.
Now,
Not being observed by experiment.
part of special relativity. And you go on. And it hasn't been observed by experiment, but
Has not been.
Has not been.
Yeah.
Now, relativism says if it's morally okay for you to do something, then no one can say that you are wrong. So morality also becomes observer-dependent in relativism, just as the material world does in relativity. Why don't you expand on those?
So that's it. They messed up a moral system by thinking about morals in the same sort of way that Einstein messed up physics with his relativity. So it's mess all over. But it is a bit of a diversion to go on to that.
Well, yes, I mean, this is first of all, the connection between relativity and relativism. A lot of people are interested in that. When they hear that you've written a book on that, they sort of assume that you're going to be talking about that. In fact, I don't really have this in the book because Peter Beckman urged me not to put it in because he was afraid that if the establishment, physicists and so on read this, they would think that this was my real motive for writing it, that I was objecting to the decline of morals or something like that, and therefore taking it out on relativity. So I didn't put it in the book, but as I say, there's no particular reason why we shouldn't discuss it here. And and it did strike me that there is this striking similarity that in physics, in relativity, the world is as it were, observer dependent. You move and you affect space and time. Just they somehow change, which is it's just incredibly difficult to believe.
Incredibly difficult to believe, and it's absurd really. It's nonsense to have to mess up the maths in that sort of direction. So messed it up in physics, and you mess up your moral systems.
They somehow change, which is just incredibly difficult to believe. And that is what, in fact, Peter Beckman said, no, I can't believe that. There has to be some other way.
Some other way. So Beckman's saying it has to be done another way. You don't want to mess it up in that direction. Einstein messed it up in that direction.
And then you get the same, and then you realize that you have the same thing in relativism, where morals are somehow, each person can have his own morals, because we hear this said all the time now, if it feels right for you, then do it. If it's okay for you, then it's okay.
So you've messed up physics by this sort of way of doing things, and you messed up morals by this way of doing things. With moral relativism, it doesn't matter whether you're good or evil, any point of view is good enough. So it's total mess up, and then it leads to corruption and collapse of society.
And so this is basically the same sort of idea. And notice also that the whole thing happened also in quantum mechanics, which came along at about the same time as relativity. A little bit later, 10 or 15 or 20 years later, it was argued by Niels Bohr and others that a particle's position could not be completely determined, because in the act of observing it, you affect what you are observing. So again, reality becomes observer dependent. Now it's interesting.
So reality becomes observer dependent in quantum mechanics as well. It's the same sort of belief. It's going into that. So it's corruption of that as well from that direction. Is a very big corruption and influence on things.
So again, reality becomes observer dependent. Now it's interesting that Einstein himself, this was later on by the 1930s, he did not really go along with this. He said, no, you're just taking what was measured with fairly primitive instruments and coming to conclusions. Maybe that maybe there's some other way of looking at this, and he tried to hold out against it.
So what happened was Einstein opposed quantum mechanics, and quantum mechanics was based upon the same sort of thinking Einstein had in 1905. So it's then taken to be that Einstein changed his mind about things. Einstein sort of had a philosophy, an ideology, political beliefs and so forth in 1905, and that led him to believe the sort of things he did then. And later on he sort of like rejected that sort of way of looking at things. So he sort of like rejected quantum mechanics, which was based upon building things in that direction. And what happens then is with the arguments that Einstein got into over quantum mechanics, the establishment then decided to ignore Einstein. They picked up what he was saying in 1905, went with it, and then they ignored him when he changed his mind about things.
And in fact, I think Einstein in his later years became really more conservative, more politically conservative in a way.
So becoming more political conservative. So he's pointing out here that Einstein is changing his beliefs.
He had a radical period in his youth when he came up with the special theory.
So he had a radical period in his youth, and then later on as he got older, he became he had changed his views a bit about it, but by then he'd got this special, his general and special relativity built upon his radical views of his youth, and so he's going against what he did in his later years, wanted to do things different, but he's got too much being built on what he did in his youth by the physics establishment, which has now taken up those ideas and rejecting what the older Einstein is doing.
And in fact, I think Einstein in his later years became really more conservative, more politically conservative in a way. He had a radical period in his youth when he came up with the special theory of relativity, and then he tried to go against it, against quantum mechanics. And as an eminent physicist at Caltech, Carver Mead, who was more on Einstein's side on this quantum mechanics thing, said, if they could put him down, you know, as famous as he was, they could push him aside. Think what they could do to you, you know, and this is the world that we still live in. So funnily enough...
So that is the world we live in. Einstein had his radical views when he was young, and as he got older, he changed his point of view on things, but by then it was too late. The establishment had gone with his radical, youthful ideas, and when he tries to go against it, tries to buck the system, the establishment just discards him. So in his later life, the physics establishment is ignoring what Einstein is saying. When Einstein's going against quantum mechanics, they're ignoring it.
Think what they could do to you, you know, and this is the world that we still live in. So funnily enough, I think I thought the great irony would ultimately be if it was shown that Einstein were wrong about relativity, but right about quantum mechanics, and everyone has assumed that it's the other way around, you see. So
the point of view of the establishment is Einstein is correct about relativity, Einstein's relativity is correct, and Einstein is wrong about quantum mechanics. And Bethell's point of view is that Einstein is wrong about his relativity and correct about quantum mechanics, so it's ran the other way. And we can see that from Einstein's youthful phase around 1905, when he was a radical, he had his beliefs, and both Einstein's relativity and quantum mechanics were based upon those sort of beliefs. And when he got older, he went against those sort of beliefs. He still wanted to go with his relativity because that's what he personally put his effort into doing, so he was still wanting to support that. But when it was quantum mechanics, he wanted to go against that. He didn't want to go in that direction. So basically, in his later life, he was sort of should be that his later life he should have said his relativity was wrong. He should have gone against it. So then the correct point of view is Einstein's relativity is wrong, it's nonsense, and correct point of view is that Einstein was correct about quantum mechanics. It shouldn't have gone in that direction. So the problem is Einstein, I suppose, closest to coming to saying that his relativity is nonsense. It's just basically saying things he doesn't understand it. We've got all those quotes about him saying he didn't understand it. So, but that's the closest we got on it.
I kind of enjoyed that thought.
Tom, when you were a student at Oxford, what was the focus of your studies?
Well, it was scientific to a large degree. I mean, I did philosophy, physiology, and psychology. And psychology was of the rats running in mazes kind of psychology. And we also did a lot of philosophy of science, where you learned what was the meaning of a science, what is really a real scientific theory, and you had Karl Popper and you studied all that stuff. So it was actually quite useful.
Where did you learn how to write?
Where did you learn how to write? Unfortunately, it's now a diversion onto writing style, writing skills and so forth. So we've got to pick it up now after this diversion. It's a diversion onto writing, then it was a big advert break, and then it was unfortunately the next bit is the conclusion. So that's after the diversion. We're picking it up now, and unfortunately we're on to the conclusion. The interview is almost over.
Relativity necessary, a must read. If you're interested in the issues we discuss on Roundtable, check out our website, conservativeusa.org. Fax us your name and address free of charge. We'll send you literature, 703-281-4108. Tom, what closing comments do you have?
First of all, I got interested in this partly because of what Peter Beckman told me, but also because, like many people, I think almost everybody, you ever try to read these easy Einstein books about relativity, it becomes impossible to understand what...
It becomes impossible to understand these books, which are supposed to be easy to read Einstein relativity books. Really, you should be saying that what you understand from these easy to read Einstein's relativity books is it's nonsense. You should be looking at it and saying, this is nonsense, what they're telling me is nonsense. But instead of saying it that way, you're looking at it and it's saying it's impossible to understand.
Also because, like many people, I think almost everybody, you ever try to read these easy Einstein books about relativity, it becomes impossible to understand what's going on at a certain point. You suddenly find yourself totally out of your depth.
Suddenly find yourself totally out of your depth. You can start off and it sort of makes a sort of sense, then you carry on reading and it becomes, oh, this is nonsense. But they're saying you don't understand it. So this is the valid way of looking at it. You should be reading it and after a certain time you're saying, this is nonsense. What you're reading is nonsense. You should be coming to that conclusion. But instead of saying that, people are reading to a certain stage and saying, I don't understand it. It's the same thing when you get into a point where it doesn't seem to make sense anymore and you're saying you don't understand it. The conclusion you should be reaching is it's nonsense. Unfortunately, you're getting too many people of type 1A who are reading these things, reading Einstein's relativity, and when they get into the bit which is nonsense, they're still carrying on believing it. And so from the point of view of type 1B, those people are deluded. They have serious problems of thinking.
And it's not because the math of special relativity is actually quite easy. It's high school algebra, no more than that.
High school algebra, it's easy maths really. Starts off reading special relativity, and if you've got decent mathematical skills, it's rather easy maths. Just basic easy maths. But then suddenly you get out of your depth and you're saying it doesn't make any sense. And you should be concluding that it's nonsense when it doesn't make sense. But instead you're trying to dismiss it as you don't understand it.
Point is you suddenly find yourself totally out of your depth. And it's not because the math of special relativity is actually quite easy. It's high school algebra, no more than that. And so I thought, well, I've got to write this in a way that makes it simple for people to understand, and I hope we have done that. The general consensus of feeling is that Einstein's special relativity is true and has been proven over and over again. And
that is the general consensus of special relativity, that it has been proven. But when you actually check on it, you find out that's nonsense. They're just making a false... People who believe in special relativity are making a false representation of it. As I went into on this talk, the lie on which Einstein's relativity is built, they are falsely representing special relativity, and they are falsely representing experiments. When they talk to physics students, they are telling them basically a lie, and lots of lies basically. They're just totally misrepresenting experiments. They're not representing what's really going on. So when it talks about the basic view from the establishment on special relativity that it's correct and confirmed by experiments, they are totally misrepresenting those experiments.
Einstein's special relativity is true and has been proven over and over again, and general relativity, which is much more complicated, involves gravity. Well, that maybe need a little bit of correction and change.
30 seconds.
But I come to a different conclusion. I can come to the conclusion that special relativity is definitely wrong. It has been shown to be wrong.
There you go. He's saying his point of view, special relativity is wrong and it's shown to be wrong, and you can actually go to the experiments, and if you understand the experiments properly, there is what we would call a small ether effect, which means there is a change in light speed, and so when these people who believe in Einstein's relativity special relativity start talking, they are falsely representing those experiments. Einstein's special relativity is wrong if you are taking light speed postulate that it's constant.
Different conclusion, I can come to the conclusion that special relativity is definitely wrong. It has been shown to be wrong. There is an east-west difference in the speed of light, which gets to that your original question.
East-west, speed of light. So the speed of light changes. Speed of light is variable. It's not constant. That's if you're looking at experiment without defining the speed of light as constant. If you're not defining the speed of light as constant, then you are actually finding that the speed of light is variable.
West difference in the speed of light, which gets to that your original question. General relativity, on the other hand, does seem to give the right answers, but by a complicated method, and if you use Beckmann's assumption, you can get there without relativity.
Tom, next time you're here, be sure to wear your Balian ring.
So on that last point about general relativity, general relativity is a bit of a mess, and I've done this talk we looked at is by Professor Roger Ryden on general relativity, and when you fully analyse general relativity, the maths of it, it does start ending up coming out as nonsense. So also Crothers would have gone into more details about that sort of thing. So when he's saying that, so we pick it back up again.
Has been shown to be wrong. There is an east-west difference in the speed of light, which gets to that your original question. General relativity, on the other hand, does seem to give the right answers, but by a complicated method, and if you use...
So general relativity, he's saying, seems to give the right answer by a complicated method, which is to some extent true, but when you do look at it into more detail, general relativity starts coming out as nonsense. And so that is the pretty much conclusion of this little interview.
Assumption, you can get there without relativity.
Get there without relativity. So you can actually do things much easier without Einstein's relativity. What you've got is a lot of lies, misrepresentations and so forth, and false claims by the people who believe in Einstein's relativity, if we go back to them. So for the people of type 1 who decide they understand Einstein's relativity, it splits into two groups. Type 1 look at it and it makes sense to them, but if you look the other type 1b, look at it and they decide it's nonsense. So that's their understanding. Our understanding of type 1 people is that Einstein's relativity is nonsense. And we look at type 1a people, and type 1a people are making false claims and so forth, and it looks to us that they are totally deluded about things. So that is a bad status for dialogue between these two groups of people. If we're looking at these type of people as being deluded, then we find it's impossible to communicate, and these people at type 1a are looking at type 1 people who are saying that Einstein's relativity is wrong, and they're working from a position of trying to be very nasty in calling these people crackpots and so forth. So dialogue just becomes impossible. So that's it. That's the end conclusion. Thank you.